So one of the things on lesson 1 that you have to remember is what the transformations were from last chapter, because now we're talking about the properties of the transformations. Okay? So if we talk about reflections, what word did we use to reflect? What word did we use? Anybody? Flip. What about rotate? What word did we use? Turn. What about translate? What word did we use? Slide. And the last one was dilation or dilate. What word did we use? Resize. Very good. Okay. So those were our 4 transformations. And again, when we're thinking through these, now it's going to be looking at, okay, which transformation happened? What does that mean for that shape? What parts are the same? What parts are different? Is the whole thing the same? How can we name that? What sort of statements can we give with congruence and similarity? That's more of like what we're doing in this chapter. If we know they're congruent, what can we do to solve? If we know they're similar, what can we do to solve? Okay? So it says, if a transformation produces an image with the same shape and same size as the pre-image, the figures are congruent. If they are the same shape and size as the pre-image, the figures are congruent. Does anybody remember, it came up on our review and our test, what symbol does it look like for congruent? What's it look like? Yeah, that equal sign with a wave. I tend to call it kind of a swiggle. Okay? Congruent is just a fancy way of saying equal to. Okay? It's like the geometry version of equal to. Okay? So congruency, you always want to think about the equal sign, and then it just has that squiggle on top. And it says a congruency statement for the triangles shown would be, well, if triangle, we use the symbol to name it, and if I call it triangle ABC, that's this one, triangle ABC, and if you look at these two, are they the exact same shape? Are they the exact same size? So they are congruent, so I'm going to put the congruent symbol. So triangle ABC is congruent to, and we'll talk about this more in the next lesson, but they have to match up with the corresponding parts. So if I name it A, B, C, I have to go in the same order, A prime, B prime, C prime. So triangle A prime, B prime, C prime. So I would read that. Triangle ABC is congruent to triangle A prime, B prime, C prime. Okay? What transformations that we talked about at the top give me congruent figures? So same shape, same size. Give me one transformation that results in congruent figures. Olivia. Good. Reflection. Aubrey, is there another? Translation. Is there another? Rotation. Is there another? No, because the last one changes the size, and to be congruent it has to be the exact same shape and the exact same size. So anytime today that we see something that's a reflection, translation, rotation, we know they are congruent. Otherwise, they will be similar. So it says, if a transformation produces an image with different lengths, so different length sides, and equal angles, the figures are similar. Different length sides, I guess I didn't have to make that plural, sorry. Different length sides and equal angles, the figures are similar. Now, I don't tend to use that definition for similar. I tend to say that it's the same shape different size. Okay? That's what I tend to say. Same shape, different size. So congruent is same shape, same size. Similar is same shape, but different size. Okay? So then, what transformation produces similar figures? Dilation. Anybody have an idea what the symbol for similar is? We haven't talked about this before. This is new. Any guesses? Did you have a guess? So it wouldn't be the equal to because they're not both the same thing. So we basically just take out the equal sign. It's the squiggle. Okay? It's that little wave, as Kylie said. So in this one, if I name it triangle, and I'm going to go a different order. We usually go alphabetical order, but I'll go a different order just to see if we can come up with the order for the letters. If I say BAC, so triangle BAC, and I'm going to use, these are similar because if you look at these two pictures here, they are the exact same shape. They're the same triangle, but they have different sizes. So it is similar to triangle. How would I name that other one based off of how I named the first one, Carly? If I said BAC, this one I have to say, very good, B prime, A prime, C prime. Nice job. And something I talked about in the last class, I didn't write it down on the first class notes, but when we talk about the same shape is talking about the angles. Okay, the same shape is talking about the angles, where the size is talking about the side lengths. Okay? So if you think about these two, like angle A is a right angle, so angle A prime is still going to be a right angle. The angles are the same, it's just that they have different side lengths in between. Like if I made a triangle, okay, if I made a triangle and I go to make it bigger, notice I am not changing the angles here, I'm just changing the side lengths. Okay, that's what it means to be similar. That was just what it means to be the same shape, just a different size. Okay? At the bottom, it says, describe the transformation shown. I like to use highlighters today because, honestly, they try to trick you on some of these. Some of these look like, oh, I just did this, but when you pay attention to the corresponding parts, and again, corresponding parts is something we'll talk more about in tomorrow's lesson, you're going to notice that something else happened, a different transformation happened than what you think. So when we use our highlighters, we're going to try to match up the letters. So pick up any color, doesn't matter what your color is, and if I highlight A to B, that means on the other side, I'm going to go to the same letters. But this time it's not A, it's A prime to B prime. Very good. And I have 3 colors out, so I'm just going to do all 3 sides, even though, honestly, at this point, you might know what transformation it is. If you know, you could really stop highlighting. Okay? So I'm also going to do A to C, which means I would go A prime to C prime. So match up the letters. And then B to C, I'm going to do in a different color, so B prime to C prime would be in the same color. So raise your hand if you can tell me what transformation happened. What happened to go from my pre-image here to my image over here? What happened? James. I reflected. Very good. Can you be a little more specific? Reflected over? Great. This is my y-axis, and that's what it flipped over. So reflection over the y-axis. Deflection over the y-axis. Good. And then it says, what do you notice about the corresponding side lengths? So like the one I highlighted in pink and the matching one in pink. What do you notice about those side lengths? Or the one in yellow and the one in yellow? They're the same. Very good. What about the angles? If you would look at angle A here and angle A prime here, what do you notice, Hallie? They're the same. Okay. So they are the same. If the side lengths are the same and the angles are the same, that means it's the exact same shape, exact same size. So Valeria, is that going to be similar or congruent? Congruent, very good. If everything's the same, they are congruent. So we want to make a congruency statement. So I'm going to say triangle, and again, we typically go in alphabetical order, but just to see if we can get the letters in the right order, I'm going to do C-A-B. And Alexa, congruency statement. So I need the congruent symbol. What's that look like? Squiggly line with, look at the congruence at the top. It's more than just a squiggle. More than just a squiggle. With what underneath? Equals. Yeah, very good. So we need the equal sign with the squiggle. That's congruent. And anybody, if it's triangle CAB, this one's going to be triangle. Very good. Okay. Any questions on that first one? On the next one then, again, I'm going to start with my highlighters. Okay. So if I highlight side AB, Chelsea, what other side should I highlight in that color? If I highlight AB, in the other triangle, very good, A prime, B prime. Nice job. Okay. Braden, if I do BC in the other triangle, I should do? Very good. And honestly, you can stop there. Again, most of you at this point probably already know what the transformation is. I'm just going to go ahead and do the last side. And they kind of run over each other, so I did the second one down a little bit just to make it so you could see it. What transformation did we use? Go ahead. Good. And because we like to be specific, anybody know what our scale factor is on this one? I want you to really look at it, because I will tell you, the last two classes, they could not get it on their first guess. It was kind of just guessing game for them at first. So look at the pictures and see if you can figure out what scale factor was used. Jackson, what do you think?
3.
It was 3. Very good. You kind of said it like a question. So was that more of a guess, or did you have a way you figured that out? Gotcha. Okay. So what did you do to figure it out? Side lengths. Okay. You could definitely do the side lengths. This side length was 2. This side length was 6. So 2 times 3 is 6. James, did you do it another way? Because it looked like you had it figured out. Or did you do it the same way?
I just did like B.
Okay.
B prime divided by B equals 3. And like C prime divided by C equals 3.
Yeah, you looked at the points then. Perfect. Okay. So the points would be like 0, 2, and 0, 6. Okay, so that's another way to do it. Okay. Not something you have to do specifically today, but it's just kind of a good thing to know for this chapter. So what do you notice about the side lengths? If you look at my green side and my other green side, what do we notice? Haley. If you look at this green side and this green side, are they the same? Are they different? It's different. So we're going to say the side, I'm going to actually say the sides are longer, because it did get bigger with a scale factor of 3, so the sides are longer. It also asked about the angles, and second period really kind of struggled with this. If you're looking at it, if you were looking at like angle B and angle B prime, are those the same or different? They really struggled with this in second period. What do we think? They are the same. Guys, remember what we talked about up here. Similar, a dilation means they're the same shape. The angles are all the same, just the side lengths are different. Okay, if I would pick this up and put it right on top of here, this triangle would just look like this. So it's the same angle, it's just not as long of lines. Okay, so the angles are equal. Angles are equal. So if we think this one through then, Mari Carmen, is this going to be similar or congruent? Similar, yeah. If everything's not equal to each other, then it can't be congruent. So when I do this one, if I do triangle ABC, and Aubrey, what's the symbol for similar? The squiggle. We would say triangle, and anybody, we would put it in what order? Very good. Any questions on those? If not, flip it over. Sorry, my camera's kind of going crazy. It's flashing a lot up here. Okay. On the back side, we're going to do the same thing, okay? We're going to try to write down the description, as in what transformation. We'll use the rule. This is more of like the concept going back to last chapter for the rules. And I'll be honest, this one, a lot of people would get this one wrong without using highlighters. So let's go ahead and try to highlight first. Okay, if I highlight side AB, Rain, what should I do in the same color? Very good. I'm going to try to get this to be a little more clear. There we go. A prime, B prime. If I would do Braden BC, I should highlight, yeah, B prime, C prime. And honestly, at this point, I know what it is. So I'm going to stop highlighting. If you don't know, you could keep highlighting the sides that go together. But what happened in this one? James? Very good, and you were specific right away. So it was a reflection, and you already told us I was going to ask over what, and that was the line was the x-axis. So over x-axis. And I will tell you, without the highlighting, a lot of people tend to think that's a translation. They think, oh, we just slid it down because the shape looks the same. However, if you look at the colors, if we slid it down, this top part would be yellow and this top part would be green. But instead of being at the top, now it's at the bottom. So that was a flip. Okay, good. The rule, remember, if we reflect over the x-axis, which one stays the same? X, what happens to the y? Opposite, very good. When it's a reflection, are these congruent or are they similar? Congruent. It was the exact same shape, exact same size. So I'm just going to write that off to the side here. It didn't ask, but that way we are kind of paying attention to this. The next one, let's highlight sides. Let's see, Carly, give me two sides. It really doesn't matter what we start with. HK, so I would also do H prime, K prime, very good. And again, if at this point you know what transformation was used, you don't have to keep highlighting. I'm going to do one more highlighting. So what else should I do, Valeria? I couldn't hear you, I'm sorry. I and J, so then I'd also do? Very good. So if you look at those, raise your hand if you can tell me what transformation was used. Hallie? Yeah. Oh, sorry, go ahead. But that's not how we describe a translation. Translation, we say which direction and how many units it moves. So hold on, let's write translation. So Hallie, which way did it move? Left. If you look, it went that direction because that's the direction of the primes. So it went left. How many units? Be careful on this one, guys. How many units? Jackson? Not 14. It's not 10. It is 9, okay? So I have a lot of mistakes on this because I either have people do this, they go from the outside to the outside, or they go the inside to the inside, okay? You have to go from one letter to the same letter. So if you're going from H, you have to go to H prime. The 10 comes into play when people count the first point as moving 1. That's not moving 1. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So translation, 9 units left. 9 units left. Okay. The rule for this, anybody remember what it looks like for a translation? What do we do? Do you remember? Very good. X minus 9, because on our x-axis we subtracted 9 from each value to move to the left. Did we go up or down, guys? No, so our y value stays the same. On this, congruent or similar? Yeah, it's congruent. They stayed the exact same shape, exact same size. Good. Okay, I'm going to give you about 2 minutes. I want you to try the next 2 on your own, okay, and then I'll go over them. I would definitely use the highlighters to help. People tend to miss some of these if they're not using the highlighters. Bless you. Okay, a lot of people get tricked on this one. The highlighting definitely tells you something different. A lot of people think at first that it is a flip. Okay, I had a lot of people that I went over the answer and they were erasing and fixing it because immediately it looks like it's a reflection. However, if you actually highlight your X and Y and my X and Y, you will notice those are not flipping. Okay, some people were just highlighting this side and being like, oh, yep, it flipped, and stopping. But no, if you look at the rest of them, you can tell it wasn't a flip. What actually happened here? A rotation. How many degrees? How many turns was this one? 90 degrees. It was one turn. And this part tends to trick people, okay? Because a lot of people are looking at it and they're like, okay, it's going up there, and they're like, ooh, that's left. Left is counterclockwise. However, remember, you always start at the top of the clock. So if I'm going this way, what is that, guys? So that's really what direction? Clockwise. Very good. For the rule, remember we said 90 degrees, we do what? Switch the order. Very good. And then clockwise moves to the right, so we make the right one the opposite. Okay? Congruent or similar? Congruent or similar? Congruent. Same shape, same size. Very good. We did not change the size. There was no dilation. On the next one, I did O and N and O prime, N prime for highlighting. And then I did P and L and P prime, L prime. Honestly, it doesn't matter what side you highlight, as long as you can tell what happened. Jackson, what happened? Ooh, you were even more specific than I was hoping for, because usually I have to say, okay, which way? And then we discuss in class, did it go clockwise, did it go counterclockwise? And half the group thinks one way and half the group thinks the other way. You are both correct. Remember, if I go 180 degrees this way, or if I go 180 degrees this way, you end up at the same spot. So it really doesn't matter if you put clockwise or counterclockwise. Okay? I might even just leave it like this. For this rule, do we switch the order? No. But we do, which one? Both become the opposites. Okay, I want you to get started at the bottom. And you only have about a minute, so work until the bell, and then you can pack up. Okay? On the bottom, you're going to write the description at the top, rule at the bottom.